G'day everyone, thanks for coming. Today I'll be doing a quick overview of my GLIntercept tool, which has been around since around 2003, so it's roughly half the age of OpenGL, which is in its 20th year this year. So, one extra person. Yeah. So anyway, I'll just be taking you through just some practical examples of how to use it and some of the features that are available in it and its limitations. So anyway, if you go to the GLIntercept website, you can download there's two exes. You can also download the source. It's open source, MIT license. So there's 64-bit and 32-bit, and that's for if your application is 64 or 32-bit, not if your operating system is 64 or 32-bit. So the way GLIntercept works is the way that a lot of these tools work is it's a DLL proxy. So after you've installed it, I've already installed it on this computer. By default, it'll just throw it into program files. GLIntercept 1.1. So the important thing is, once it's installed, there's no real GUI or anything that's associated with this. You don't actually need to install it. If you want to, you can just unzip it and set the paths correctly in the config files. So basic usage is to just select the proxy DLL and a configuration file. There's several pre-configuration versions with different settings, which I'll run through. But the basic usage is just select these two and just copy them. And I've got some example apps. Just copy them in the same directory that the exe is in. You can do some complicated DLL pathing and stuff if you know how Windows finds DLLs and that. But this is the basic thing. Just put it next to the DLL and it'll run. So then just run your exe, and it should be running. So I think by default that the initial one will just dump out a text log. So this is very, very simple basic logging. So it's just a straight text file of all the OpenGL calls that were generated. And it will also throw out a log file which will tell you of any errors and things that it's detected. That includes resources that have been allocated that you haven't freed by the end of the application and those sort of things. Okay, so I'll just take you through some of the more advanced features. I'll show you what the website actually looks like. So, if you go to GLIntercept.google.com, whatever, or the project's website, and it's hosted on, this is what you'll be presented with. So, probably one of the main features of GLIntercept that's different from a lot of other DLL proxies is that it will automatically handle newer versions of OpenGL without actually having to. That's right. So yeah, as I was saying, the reason GLIntercept's had such longevity without massive amounts of updates to it is that with each new version of OpenGL and all the extensions and stuff that get released on even a monthly or yearly basis from ATI and NVIDIA. It will automatically handle basic logging straight away. Now the way it does that is that instead of overriding every single function, what it does is it intercepts a thing called the WGL get proc address, which is mandatory pretty much if you want to use modern OpenGL to get all your entry points into OpenGL. You can't just directly link against the driver. There's an intermediate layer that you have to go through, and I take advantage of that fact. So all the pointers that get returned, I wrap them in some assembly and then return them to the user application. So no matter what extensions will come out in the future, it will automatically wrap and then return. So it will show up in the log. So that'll add a log entry for each function call that gets made, but it obviously doesn't know what arguments are there unless they're specified. But yeah, so GLIntercept has a very, very basic text file syntax that it just reads off, which I just go through occasionally and fill out, which is essentially like the C definition of the function call. So it knows that when this function comes through, that it's kind of got these arguments of these types, and it knows what to do internally. It inspects the stack and that for each of those arguments, and then pulls out the appropriate values.
How do you intercept that WGL get proc address?
WGL proc address is exported by the DLL.
Oh, is that part of the normal OpenGL DLL?
Yes, correct. The normal OpenGL DLL only exports on Windows OpenGL 1.1 and a small subset of the WGL stuff. But yeah, get proc address is included in one of those. So that's a special wrapped one. So some of the features that are available. You can get your logs in either plain text, as I just demonstrated initially, or XML format. A slightly newer feature is the ARB debug output messages that are actually generated by low-level drivers saying something went wrong here, or there's a performance warning here, so that if you're doing something slightly strange that the driver has to account for, you can now get messages back. And so now I'm logging those messages and inserting those into the logs. I'll take you through a few demos demonstrating a few of these different features. A feature I added way back in 2005 was a runtime shader editor, where at any point you can just pull up a shader editor, inspect what shaders are on each item in the scene, and then manually change them and compile them back into the application. And as you can see, it's supported the assembly level shaders, and obviously most recently the GLSL and even the NVIDIA ancient extensions on that. If you're using fixed functionality, part of OpenGL, this doesn't work with shaders, is you can get access to a free camera where you can take control, where it essentially intercepts the model view matrix that has been passed down for rendering, and you can actually fly around your scene to see how your culling is working, display the view frustum, and different things like that. Usual save and track textures, so you can see how your textures are being uploaded, verify that they're being uploaded correctly, and make sure that you're actually deleting them when you think you're deleting them. So if you get to the end of the application, GLIntercept, if you've got that option turned on, will say, okay, you didn't delete all these textures, so you might have a texture memory leak, which isn't a particularly bad thing, but if you're chewing up a lot of texture memory and there's some textures that are from your intro scene or something that you still haven't freed, you're obviously using more resources than you need to. Shaders and programs tracks display lists, which are quite an old feature of OpenGL. Tracking the frame buffer, color, depth, and stencil, and it'll take a snap. You can set it up to take a snapshot before and after each render call, and then generate a diff image on each render call, and it'll highlight which error has changed on every render call. Track error states. There's a lot of options in that. If you're running through a debugger, you can have it so that every error is actually dumped to your output window, and you can configure it to throw a breakpoint when an OpenGL error occurs. It does some basic thread error checking to make sure that you're using your OpenGL context on the thread that it's actually supposed to be active on. That's a common source of a lot of errors when you're using managed code, as in people do a lot of the OpenGL destruction code inside finalizers and that, which you should do because finalizers are usually running on other threads, which mean they don't essentially get called at all on the OpenGL state. Basic function time logs, like I mentioned before, resource tracking. OpenGL extension version overrides, so if you want to see how your application will fall back gracefully, assuming that you're doing proper versioning and checking. inside your application. You can like knock out OpenGL extensions, or set your version lower to see how your application is going to run. And if you're playing with really new features, it's quite common for OpenGL drivers to expose features like all the entry points without actually exposing the extension yet, if it's still experimental. So what you can do is like you can add an extension and say it really is there if you're playing with really new stuff. And function stats are just saying, okay, for every at the end of the application, just how many times have you called each individual function, and it'll sort it by alphabetical and call frequency. So that's most of the things. There's quite a few other tools that do similar things. API Trace is one of the newer ones. So it can do, it's more of a capture and then replay sort of thing, kind of like what Pix does. Mine's more of a interactive while you're actually developing sort of application. There's pros and cons of each, but API Trace has got the big advantage that you can capture a state and then send it to someone else, and they can just replay those commands without actually having the application. GDebugger was a commercial one that was been around for a long time as well. So anyway, yeah. So I'll just show you some screenshots. So these are just some screenshots of some of the different things that you can generate. So this ARB debug output, which was actually just added quite recently, is in like the last couple of days. Like you can kind of see messages from internal OpenGL saying, like as you can see here, it's saying that program shader state has changed and has to recompile the shader for some particular reason. XML logging.
Where does, sorry, go back one. Where does that? What does it actually log to? Just over the top of the actual app, over the top of the.
No, these are. I'll do a demonstration after this, but yeah, it's essentially it's generating an external XML file that you can view after your application.
Because you've got some like, images embedded in that, is that?
Yes, correct.
You can do that from the XML somehow.
Yeah, it's XML that's formatted through some XSL processing to generate a HTML thing that browsers can view. So anyway, so this is an example of some XML stuff. Like you can kind of click on images and stuff, and click on source to actually see the source and shaders and bits and pieces. This is just a screenshot from an old Visual Studio, obviously. You've got the option to throw your errors to your output window, so you don't actually have to do things. Different errors. This is just examples of overriding extensions and version strings and things like that. Actually, overriding the version string was actually quite important quite a long time ago when OpenGL went to OpenGL 2.0 back in, just mentioned 2005 or whatever. A lot of apps actually broke because they weren't actually checking the first digit. They were checking 1.4 or something, so they're only checking the second digit to make sure that was greater than. So quite a few commercial applications linked, saying, okay, this is a way you can fix our, until we get around to fixing our code, was to install GLIntercept and run with this config file to override the version string. Okay, this is an example of the shader editor. I'll do a live demonstration of this. I've got that application there, and this is an example of the free camera. This is Wolfenstein enemy territory, so you can kind of bring up a Frostman coal and fly around your geometry to see what actual geometry is actually being sent. This feature doesn't really work in modern OpenGL with all these shaders and stuff going on, so it's only if you're doing really basic stuff that will work. Okay. I've got a readme from the website, but I don't think. So this is the readme that gets thrown in when you install the program, but I'll be going through all these options anyway. So plugins. Okay, so back to the demo. Okay, so from that initial run, from that initial GLI config file, this is what it has. It's kind of like got comments through it. It it supports standard C style comments, so you can do line ending stuff. So I'll just put it down here. So included in the base config is like the image loggers, the shader loggers, and the display loggers, and the frame logger. But most of the newer functionality is done through plugins. So you have to kind of go to this plugin section and say, okay, I want to load in plugin blah, and here's all the options for the plugins. So that initial run that I did before, it was set up with the image and shader logger and also just the basic text logger. You saw the text log before. And it created a subdirectory called shaders and images, so you can inspect each of the shaders that were used, or if you want to, you can inspect the images that were used in the application. So I'll just do a slight change to this. I'll enable the XML login. Oh, it's probably read only.
You hit save as I think.
I did it. Okay. And I'm going to enable log per frame. Now what log per frame does is instead of starting the logger immediately, you can hit a key combination to turn it on or turn it off, or if you only want to do one frame, which is the typical scenario that you're viewing something and you see something going wrong, you can just grab a frame and it'll just save out the log just for that one frame. So I'll just run that again. So you can kind of see it pause as it's grabbing and stuff. And you can see it's generated this folder called frame, and that's just the frame number. So it essentially generates this XML, and it copies this guy and this guy into the same directory with it. So this is just some XSL formatting to format all this stuff as a HTML page, and this is just a helper thing for viewing Internet Explorer, because a lot of browsers nowadays, they don't like running things locally, unfortunately. They won't let JavaScript and things like that run locally for security reasons that are too complicated to explain. So, once you've grabbed a log, this is roughly what it looks like. You can click on these guys, you can view shaders, you can view the textures. And I'm just going to enable one extra feature, enable frame log. So frame logging's got a lot of options, how you want to save things and things like that. Whether or not you want an icon file, you want to output a movie, what color buffers or stencil or depth buffers you want saved, and if you want the pre, post and diff saved with it, buffer before, buffer after, and the difference between them. So, on this one, as you can see, it's now saved out the color buffer. So they're not clear in the screen before and after the frame here, so it's not as noticeable. But that's the frame from the previous. That's what the frame buffer looks like. It's not resizing, but anyway. After, and this is the diff. So essentially, all the non-green areas is all the bits that were rendered on that render board. So So you can kind of see here, rendering the ground with that map. That's where it touched.
Do you literally do like a pixel by pixel comparison?
Yes.
Yeah.
So yeah, if you've got the frame, like the overhead of GLIntercept is not very high as long as you're not actively logging sort of thing. So what I usually do when developing, I just enable the per frame logging and just throw it in the debug directory, and then whenever I need it, it's there. I just grab it from it.
Do you log out? Do you logging in a separate thread or anything like that? So? That's what we did with Investigate. Basically, do the file, outputting the file in a separate thread, so you can just keep logging. It doesn't really affect the performance.
Yeah. Okay, so I'll just show you. I'll get more options. So, as I said before, like a lot of these have like pre-configured sort of stuff, but I've thrown most of the options that I like using as an author standard configuration. So if I run that again, that's got a few things. I think Control-Shift C invokes the. So this is the free camera. So this is not. I don't think this is. Yeah, you can't see. They don't do a screen clear, so you can't see. I can actually go outside, so I'm actually moving the camera.
I thought it would pause when it did the free cameras.
Pause?
Doesn't it pause the kind of state when it does a free cam?
No, it kind of just relies on the fact that it's going to be relatively constant matrices. Well, it essentially appends an additional matrix onto the end of every matrix that's going through the renderer, and it does some logic internally to identify when you're doing orthographic to not do that sort of stuff.
It would be pretty hard to actually pause it, because it would depend highly on the whatever update logic they're using.
Yeah, like I said, it's not a perfect feature. It's just
somehow NVPerf manages to pause the application, and I think they must use some Windows timer trickery or something.
Yeah,
you just wait for a call when you to the API and then just block on it, and then run your own update loop inside your blocked function.
Could do, yeah.
Record the whole frame and run the frame over and over.
Yeah, some of them.
Just wait for like a flush or whatever, and then do it on that.
Yeah, I think some of them, if memory serves me right, they required you to get your time deltas in a certain way, so that when you're running the performance HUD thing, that you're going to generate the same frame the next time, with a 0 time delta sort of thing. So I've seen that with some of the NVIDIA tools. But anyway, so I'll show you the shader editor. So this essentially shows a listing of all the shaders. There's only one shader used in this entire thing, but if you're curious of what shader is actually active on each draw call, you can actually click on it and say, show which shader was actually used in that, and it'll just do an invert of that shader. And if you're running through a debugger, you can actually say break on shader usage, in which case, whenever that shader becomes active, you'll get a debugger breakpoint. So you can kind of pull this up and view the vertex and frame shader that's used on this. You just throw in something here like and recompile that into the application, and let's throw a little bit of a reddish hue over this stuff. It does have some. I haven't updated the tooltip stuff for a little while, so as you type different things, it has some limited registration of what the display tooltip is. That's pretty much an OpenGL 1, OpenGL 2-ish type shaders that it will do that. But you can still use this on more modern shaders, just you won't get the accurate tooltips. Okay. some of the options you can turn on and enables like insane debugging mode, which is essentially like if you've got an application that's actually crashing, you can turn all these guys on to true, in which case it'll make sure that it flushes every single log out the file. It runs quite slowly, but assuming that you get to your crash position quite quickly in your application, you can actually see exactly what the parameters and stuff you passed to the driver that made it crash. So that's got to be extended to error log and the flushing of the or the logging enabled. So I'll just quickly show you this debug context one. So what this does is modern OpenGL, to get access to a lot of the newer features, there's a concept of you can actually create a OpenGL context with debug flags, in which case the driver can report additional error information back. So this is just a way to force applications to go through that code path if they're using slightly modern OpenGL. So, okay, maybe this video card can't actually run this thing. Your drivers probably aren't modern enough to run this application. I'm sorry, I didn't see it. But anyway, what that will ultimately generate is within the log, this thing I showed you before, all the performance stuff that's coming from the drive. So, yeah, I think that's mostly everything I've got to show you. Like I said, there is a manual install if you don't have permissions to install this on a computer that you're working on. All it is just a directory and some DLLs that you just retarget. Yeah. Any questions?
Yeah. With modern shader heavy programs, is this still very relevant because you may not be able to free cam, but you can still collect a lot of useful stuff?
Yeah, I still use it quite often. Like I say, free camera is almost irrelevant nowadays unless you're still using some of the legacy stuff. But I just showed it there for completeness.
You could have letting them specify what the uniforms are so you can make the free camera still work?
Not really, because I'd imagine every single application would be.
If you can log out for a particular application what uniforms they're using, you can usually tell by the names what they might be using.
Yeah, maybe, but I generally wouldn't want to try to do that because I'm sure it might work in some situations.
But assuming you're not hacking and actually debugging your own thing, that would be quite useful.
Yeah, I suppose. Yeah.
Is there any way, like, just sort of like across the board for any app, you could sort of force a shader simplification or inject your own shaders so that the free cam could always work? You wouldn't get the same rendering, but at least you would allow you to use the free cam if you need it.
Well, considering that a lot of modern shaders, like, they're very involved in transforming the primitives and stuff to the final position, like with all this tessellation stuff, and goodness knows what is going on nowadays. I imagine it'll be quite different.
So you couldn't generate
the matrices to a shader are usually pre-multiplied as well. Like the camera matrix is multiplied through other stuff already, so you have to be trying to extract that and modify it in model, as opposed to in legacy ones where you give it each of the matrices and GL multiplies them internally. That make it hard.
Still, most people still follow the same pipeline. There's still be an MVP matrix in there that you can pull out the M and supply your own BP. Unity still does that, so you can break it in Unity again for a start.
Yeah.
Most people do it as well.
It sounds like a lot of work for a free cam feature though. You can just drop free cam into your engine.
Yeah, that's what I've
about 15 minutes.
Yeah.
You may not make assumptions with your attributes either. I mean, you may not even how easy to detect what is the position coming through.
Yeah.
You don't need to detect the position, all you need to find is the MVP matrix.
Yeah, well, it's not something I really needed, but like I said, it's open source. Feel free to hack the free camera plugin to extend its features. It's not very complicated source for the free camera plugin.
I was going to ask, well, with all the logging and stuff in there, it doesn't look like you've got a playback feature, is that right?
That's correct.
Yeah.
If you have something like API trace for playback.
Okay.
Have you thought of opening it up to a community, like putting it on source code or something?
Well, it is on, like I said, Google Code. So, and quite a bit of the 64-bit code was actually done by an Intel engineer who's doing the performance tests for their driver. So I think they're using GLIntercept internally to do a lot of their test casing, and they wanted 64-bit support, so they did it and sent it to me.
An internal engineer to what? To Google or to
Intel.
To Intel.
Like,
Intel engineer, I think everyone said internal then.
oh no, Intel engineer that does internal testing on their OpenGL drivers and things.
Oh.
So yeah, I've got submissions from quite a few people. I don't accept everything, but yeah, quite a few things I do.
Does anyone, if you had playback, I imagine one of the really useful, I suppose that's what's in all the other debugging systems like this one, is to add timers, because I've seen like a lot of this is about, one of the real problems is about 3 or 4 different timer APIs in GL, depending on what the extension is. And I can imagine it being really useful to be able to drop fences and sinks in to do timers over.
Yeah, that's something I've considered for a little while. Well, you know, at least adding in the timer interface so you can kind of see, you know, what each draw call actually takes.
Yeah.
By a plugin, but as to, you know, replay, if you want to test it on different hardware and see different performance, yeah, like I said, replay is completely outside the scope of this. It would completely mean, you know, re-architecture. Because the problem with
because of all the arguments.
Yeah, it's essentially all the arguments that are the real problem. Like, often, like, simple arguments are obviously no problem. It's, you know, it's only when, like, there's a pointer to a buffer. A lot of the older and more traditional OpenGL things, there's no real way of, without actually knowing what all those arguments are and, you know, figuring out how big that buffer is. Like, some of the more modern extensions to OpenGL, for security's sake, because, you know, with WebGL and stuff all coming in, they've added a whole ton of stuff where, you know, most buffer pointers have a size field next to them, sort of thing, so that, you know, for security and things like that. So, yeah, replay those sort of stuff would make things a lot easier, as in I wouldn't have to write essentially reams of code to handle every single option. I'd just be replaying this buffer with these arguments. So that would make things easier, but as it is, things like API trace, they have to manually go through every single OpenGL call wherever there's a pointer and figure out how big that pointer is and do tons of work. And like I said, I don't particularly want to duplicate work that other people are already doing, that's open source anyway. So yeah, like I said, this has been around for a very long time. Some people have had some success in replaying OpenGL apps, you know, a long time ago, like when everything was done with, you know, GL Vertex and GL normal calls without buffers and things like that. Yeah, they successfully did that. In fact, there was some people who've done quite a few thesis and stuff using GLIntercept to capture a frame and then passing it in through you know, scale vector graphics libraries, you know, like essentially converting, you know, your scene to I can't think of the, you know, those vector graphic
SVG files.
Yeah, something like that. And other people have done university thesis on modifying the shader editor to have like breakpoints and debugging and all sorts of other bits and pieces. So, yeah, there's been quite a few things. Actually, my most common usage of this, like probably more than 90% of all my support emails come from people
Hacking games?
Yes.
Yeah, all hacks.
Not necessarily all hacks, it's 99% of them are from people playing Second Life. Because there was a bit of a controversy a few years back that someone published an article, because apparently in Second Life, trading in skins and models and things like that is a big marketplace, and apparently somebody discovered, they weren't using it quite correctly, but they were using it enough to be able to, they were using it in a brute force method, as in log every single texture and every single thing. When a more intelligent way would have been just do what you want and then grab that. But, yeah, so I still get, every so often people say, I'm trying to use this with Second Life, and it's kind of pointless though. And I've had some of the Second Life people contact me saying, is there any way we can patch this? And I'd say pretty much nothing we can do really, because it has to be as a texture on the back end at some stage, so it's just vulnerable to getting. The only way you could practically enforce things in the marketplace would be to watermark textures in some way, so that if someone else tried to reuse that texture and you didn't have the matching watermark that you're supposed to have, we can order it would fail. But yeah, I even saw on some SIGGRAPH things last year that what's that studio in the UK? They did enemy territory and things like that. Yeah, that's them. Yeah, they use this internally as well. Any other questions?
Cool. Did you get any ideas from Ash's talk the month before?
Well, yeah, I think we might be going from a different point of view, because I'm more of a capture what you can from the frame, and then it's not too much of a performance API thing here. This is more debugging errors and things like that. I probably have to change a lot of things internally to handle performance type of. So each tools have different pros and cons. Like this was originally written when I was working at Oren, and I was doing support requests for people that were using OranJet, trying to figure out how they were messing up the render states and why they were getting what they were getting. So, and at the time, this is quite a few years before Pix came out, and there was pretty much nothing at the time.
So your main motivation for writing in the first place?
Yeah, pretty much. Yeah. And also the challenge in trying to, I had an idea that you could, intercept the get prop address call that goes to OpenGL and then wrap that into assembly, and then so that was quite a challenge to try and figure out a way of doing that so that future OpenGL would just work normally.
I think that's probably the most awesome aspect of it, is that the way you can just extend it like that automatically.
Yeah, so it's pretty much been relatively robust. There's only been 4 functions that don't adhere to that automatic thing, and I've had to do some manual overrides internally for those guys. But pretty much everything is essentially just from this header file here. So it just parses this guy. I'm not sure what this is doing. The jump to 64-bit was actually quite difficult as well, because to support that sort of same functionality, 64-bit apps don't really have a stack in the traditional sense. They're all done through registers, so that was quite difficult. So, this is essentially what the application processes on the startup sort of thing. It's a very C-like sort of thing, and that includes
Did you have to write all these header files yourself, or are they actually standard GL?
I wrote these myself. I'm not sure why this is working. Okay, yeah. So yeah, I wrote them myself, but a lot of the newer stuff is just run from there's OpenGL spec files out there, and there's just a little Python script I wrote to actually go through and convert those spec files into this sort of stuff. So essentially, there's like an enum main here, and then when you have a look at these things here, it's saying okay, there's a GL enum named of the type main, and all the different colors and things.
What is the type main mean?
That just means that there's different enum groupings in OpenGL. Most of them are in the main grouping, as in.
Oh, I see. Yeah.
But there are some other ones, like there's the bool grouping, and then there's the draw buffers grouping. And some of these are actually flags, sort of thing.
So you wrote basically a simple sort of C declaration parser, but with support for sort of relating these ints to your enums.
Yeah, essentially, because yeah, in OpenGL, every enum is just flagged as GL enum. It doesn't actually say depend. It's just a little bit more information. But 99% of them are all main, as in they're all come from the same space.
I actually wondered that when I was watching it before, because even though the API constantly changes, and you wouldn't want to have to update your code every time all the stuff in OpenGL changes.
Yeah.
But you can just download like the latest header file for OpenGL, and it gives you the function declarations for every function.
Yeah.
And I'd actually wondered whether you consider basically writing a parser for that. And then, as you mentioned, that'll tell you what the arguments are, but it won't tell you sort of what they do.
Yeah.
I almost wondered, because you will have read all like the extension text files, the extension definitions that you get from the registry. I was actually watching, like looking and wondering, you could almost write an automatic parser that tried to pull some of the information out of the extension.txt files. So just by grabbing like the standardized header file and the standardized registry for GL and dumping it in a folder, you could almost try and automatically parse it to pull some of the information into this. That's a lot of work.
Yeah, that would be a lot of work. And like I said, I do kind of already do that. Like I do have a script to parse the spec files and generate the initial version of these.
Oh, cool.
And then I just go through and then I just say, well, I just inspect, like, I don't manually type all these out myself. I just manually go through and, and look for, candidates for update sort of thing. Like, it'll automatically put the main next to these guys, and then I just go through each enum and make sure that, it is actually in the main namespace. Some of the more complicated ones where it returns strings, I've got my own internal types called ASCII string sort of things, so you can actually see in the log, the actual text string and not just a pointer. And whenever there's a texture used or a shader used, I've got my own little type there, so it will insert the texture for that number next to it in the log. If you saw in the XML log, how it has those guys